Alright, so I want to walk you through number 2 now. This is the tray problem that we looked at the other day. And it's also similar to the tray that we built before. So we're looking at this tray. It's 40 inches by 60 inches. The remaining edges are folded up to create a box because we're cutting out squares. So one thing that often helps me when I'm looking at a story problem is to draw a picture. Right? So go ahead and draw a rectangle here. And if you remember correctly from the example we did, you actually cut squares out of the corners. Now I know those aren't exactly squares, but I think you get the idea. We're cutting those squares out so that we can fold them along these dashed lines. We can fold it up and actually make a tray. Alright, now if you think about this, this whole distance right here is 60 inches. The whole distance. And this whole distance right here is 40 inches. Okay? And the height of the tray is going to be determined by how big of a square you cut out here. If you were to cut a 1 inch by 1 inch square, the height would be 1 inch. Alright? If you're going to cut a 2 inch by 2 inch square, the height would be 2 inches. So the height is the thing that we are picking. It's what we call our independent variable. It is what we are going to call our x. Alright? So it's x here, x here, x here, x here, x here, x here. So we have all these x's because they're all squares and they're all the same size square. So we're taking all those x's. Now if you look at this, so I'm going to write this over here. H equals x. Now let's talk about the length. What's the length going to equal? The length is 60 inches. So it starts with 60 inches. And we are going to take this and this away from it. Now we don't know what those lengths are, so we have to talk about them in terms of x. This is 1x, this is another x, so together we've got 2x, so we have to take away 2x. So our length is 60 minus 2x. Our width is right here, and again, we've got 40 inches, but this distance right here is not going to be 40 inches. It's going to be 40 inches minus 2x. Because again, we are taking those out. And you can put the inches in. When we write the formula, you're probably not going to put the inches in. You don't want it to kind of get in the way and think of it as a variable. Okay. So create a rule that would find the volume of the tray depending on the size square cut out of each corner. So if we were to take this, volume equals length times width times height. Okay. Right? General rule right there. The only problem is that we don't have it specific to this tray. So specific to this tray, our length is 60 minus 2x, where x is the height of the tray. Our width is 40 minus 2x, where the x again is the height of the tray. And again, the height then is just x. So now we've got our length times our width times our height. And it says, what is the size square that can be cut out of the corners to give the maximum volume? And in this case, our x again is the height, and our v of x is the volume, so we can plug this function into our calculator. So go to the home screen, do a new document, go to graphs, and you're going to plug this function in right here. So it's going to be 60, put the parentheses, 60 minus 2x, close parentheses, parentheses, 40 minus 2x, close a parenthesis, and then just a parenthesis and x at the end. So once you've got that, go ahead and see if we can get this on here. There we go, it's starting to come into focus. There we go, and hit enter. Now you probably don't have a great window for this, so if you want to figure out like the maximum or get an idea on like what values we're looking at, hit Control T so we can go to the table. And if you notice, at 1 it's really at 2,204 cubic inches, so that's pretty big. And if you keep going down in the table, you're going to see that at 8 it's as high as it's going to get with whole numbers, and that's 8,448. So I'm going to take the table off. I'm going to go to menu, I'm going to go to Window, and I'm going to go to Window Settings, and I'm going to change it to go from 0 to 20, and then my Y-min can be at 0 because you can't have anything less than 0 for your volume, and we're going to go to 10,000 so that we can kind of see what this looks like. Alright, and then I'm going to click OK. You can pause it right there if you need to see that for a second longer. I'm going to hit OK, and now I can see the graph. I can see that it's going up and coming down like this. It might be going, it's probably actually going to be going up again over here, but that's not going to really matter because that's where you're cutting so much off that you don't have a side on a tray anymore. So that really doesn't fit the situation. This graph does. This portion of the graph, I should say. So then I'm going to go to Menu, Analyze Graph, which is 6, and I'm going to go to Maximum 3, and I'm going to click on one side, I'm going to click on the other side, and I can see that at 7, close that, I can move this around now, 7.85 for X, and 8.45 E plus 3. I'll show you how to change that real quick. If I click on this, and I go to, let's see, I did this, Control Menu, and then I'm going to go, so I hit Control Menu after I clicked on that, and then I'm going to click Attributes, and I can just change it to go up to 4 decimals. And now I can see it, 8,450, right? So we can write that down. What is a square? It's going to be, I'll zoom this in a little bit so you can see it. So this is going to be 7.85 inches for the height, right? And then that's going to give us a volume of 8,450.4. There's more after that, but cubic inches. All right, and an explanation of that is just that's the maximum volume. That's the maximum of the cubic. That's that point right there. What are the dimensions of the tray that will have the maximum volume? Explain. So, again, we've got the height is going to be 7.85 inches, and then you can take the length and the width, and you can plug those in. Because remember, the length was 60 minus 2 times the height, or 2x. So I'm going to take that and put it in there and solve that. And the width was 40 minus 2x, so I can then plug that 7.85 in there to figure that out, and then get my answers over here. What square size will give a volume of 0? All right. And if you remember the height, if the height was 0, I'll slide this up so you can see it. If the height's 0, it'll be a square size of 0. But also, if the length is 30, it'll be a square size of 0. And if the width is, I'm sorry, if the height, we'll go back to his, the height is 30, it will make the length 0, which will give us a volume of 0. If the height, again, is 20, it will make the, so this makes the length 0. And the height of 20 makes the width 0. And those will give us 0. Right? So that is number 2.